Yeah, that reminds me.
I said it too.
All right, we are finishing this up.
So factor sex is.
Okay, finishing up. This is 3.5. This has to do with sketching. All right, first thing. So if I'm following the procedure, if I'm doing the steps, what's the first thing I'm going to try and figure out?
Did you upload yesterday video? I couldn't find it.
I thought I did.
I couldn't see it on your.
I thought I did too. I uploaded.
All right, so how would I check my first asymptote?
At the bottom equals 0.
Set the bottom equals 0. So 0 equals 1 plus e to the negative x. Let's clean it up. 0 equals 1 plus 1 over e to the positive x, right? Yeah. Okay, move the 1 to the other side. So 1, negative 1 equals, what's that going to be? 1 over e to the x, multiplied out, so it's negative. E to the x equals 1.
Natural log.
Right, so it's going to be e to the x equals negative 1.
So the natural log.
Actually, did I do this one wrong? No, I did it right.
We just do natural log now, right?
Okay, so ln.
It's a domain.
Yeah, there's no negative.
Hey, I'm just cool.
Says we're in its domain.
Ah, crap.
You're in my house.
Ah,
Domain.com.
okay, so,
I'm sorry.
here it is. So, I ln both sides. I just put x. I don't know why I didn't. Ln of negative x. It's a negative 1, not negative x. I am just not on track of things today. All right, so that's just going to give me x
You're right. You're on the.
equals ln of negative 1. ln of negative 1 does not exist, right?
No.
Okay, so what does that mean? Is there any places in which that this is going to equal 0?
There's
No.
No, so that means I'm not going to have,
Any vertical asymptotes.
okay, no vertical asymptotes.
You guys can't say
All right.
asymptotes because then you guys are assuming there's no horizontal or slant. Alright, you know what? I'm gonna.
F prime of x. How do you want to do this? Do you want to do a quotient or do you want to do chain?
Chain. Actually, yeah, definitely chain.
Definitely chain?
Yeah.
So if I were doing chain, I'm going to move the whole thing up, right? So it's going to be 1 plus e to the negative x to the
Negative first.
negative first, right? Okay, so if I'm doing this chain, so I'm going to go and it's going to become negative, right? Times 1 plus
Oh.
e negative x raised to the
Negative second.
negative 2 times the derivative of the inside is
Negative 1 e to the
negative,
E to the.
negative x.
like this, right?
So it's positive e to the x times 1 plus. Also, it looks like this.
It's over. It's gonna be over it.
That's if you simplify. That's if you
Oh, oh my
rationalize.
Dude, this looks nice.
Yeah, it does. I hate doing them.
What quotient have what's better?
What is that?
Huh?
No.
Quotient, you're gonna have
I'll just
something
do it.
similar, but you're gonna have to expand and all that. So it's still gonna look
Piece of
something.
cake.
All right, so what are we gonna end up with now because of that?
E to
Yeah,
the
x.
e to the negative x over.
Is it?
Okay, so let's see. This whole thing is negative, but is so let's see. Negative 1 at least
Oh wait.
over
Right.
1 plus e to the negative x
Squared.
Oh.
squared, right?
You sure you want to do change?
Yeah.
Yeah.
Times
1
negative 1 over
e to the negative x.
e to the.
Negative. All right, because it's already in the bottom.
So right there, I moved it down, right?
So we just.
Yeah.
So it becomes 1. But then you could do it.
So if I expand that, hopefully it'll clean up. Let's see if I expand it. See if I. What do I get?
Yours is
So it's going to be 1
same though. It is still negative.
plus
At least for what?
2 e to the negative x
Loki lost.
plus e negative 2x. If you expand that, right?
Foiling it?
Yeah, foiling it.
Oh.
Expanding it, foiling it, right?
He's effing that.
Effing that.
You done guilty F that?
Okay, and that's still my negative 1 there times negative 1 over e to the x. Okay, so if I distribute that, so negative negative gives me positive, right? So yes.
Yes.
Okay, the negative negative is going to give me positive, and so as I distribute this, I'm going to get e to the x.
Yep.
What's going to happen here?
E to the negative x.
Is it just 2?
It's going to be just 2. What's going to happen?
The e
Because you
cancel?
have same base, you add the exponents,
But they cancel.
They're counting.
right?
Oh, they go home.
Anything to the 0 power is 1.
Yeah. So it's going to be 1, right? So it's just going to be 2,
Nailed it.
and it's going to be plus, right?
Mm-hmm.
Let's get no better.
Plus what?
E to the negative x.
To negative x.
I'm
Yep.
definitely watching this video.
Yes, sir.
Wait,
Okay, and this is all going to be on the bottom. There's my positive 1 there.
That's your, no, that's just our first derivative still, right?
That's your first derivative, right?
That's the first.
Honestly, I feel like this is way better than bullshit.
Can we check? Can I
Chain.
Okay, so let's take a look at that. So that's still the first derivative, isn't it?
Oh, you can do our mins and maxes now.
Okay, but what's going to happen?
They're gonna die.
Okay, so now, but I have to be able to put those together, right? So I'm going to move this over to another slide. So you have this written down?
Yes.
You do you.
What do you do?
Circular.
So f of f prime of x is equal to 1 over the e to the x plus 2.
Plus e to the negative x.
So if I'm going to clean this up, it's going to just clean up the bottom. If I'm looking at this, this is going to be e to the x over 1, right? Plus 2 over 1 plus 1 over e to the x, right?
Yes.
Common denominator is what?
E to the x.
E to the x.
Okay, so if I common denominator is just going to be e to the x.
So 2 e to the x
plus
times.
2
So it's 2e.
So all this is going to be on the bottom still, remember? So common denominator, so I have to multiply, so it's going to be e to the 2x, right?
2e to the x.
Plus 2e to the x, right?
E to the x.
Plus 1. All this is going to be over
Oh, my bad. E to the x.
e to the x, right? And don't forget, it's all like this, right?
Yep.
So do we just do that?
Okay, so now I have this over this, right? I would multiply by the reciprocal. So now it's going to be 1 times e to the x over e to x plus 2x, or e to the x, I'm sorry, plus 1, right? So f prime of x is equal to e to the x over e to x plus 2e to the x plus 1.
Yeah.
Why did I want it cleaned up so well?
So it looks. It's easy.
The factor to e to the x.
When you solve it 0, it's a lot easier.
Oh, wait, because the bottom, if you multiply that over, it's going to be
The
0.
bottom's just gonna.
Yep, there we go.
Alright, like I
So now when I set it equal to 0, I did all the algebra. I now have this set up. So now I have something in the numerator now, right? Because before, if I didn't actually clean it up, I wouldn't have anything in the numerator.
It'd be 0 equals 1.
So right, yes. And so now this one right here, it's all cleaned up. There's no negative exponents.
So 0 equals e to the x.
Set this equals 0. So 0 equals e to the x. So, ln. So ln 0 equals, what is ln 0?
Undefined.
So is there any mins and maxes on this?
No.
So there's no mins or maxes. What else did we say?
The contrast. There's no vertical asymptote.
There's no acid.
No vertical asymptotes, right? Okay, so we have an interesting graph here, don't we? Okay, we have an interesting graph with all this right here. Do I have any domain errors?
No.
No, there's no domain errors.
So
Okay.
it's all concavity.
Watch it just be.
So let's see what it's gonna look like.
Whoa.
Cheater!
Hey, I'm doing that next right now anyway.
That's not.
Spoilers, right?
Oh, this is-
Wow. Very interesting. It's dead ass.
All right, so what do we have here? So it was.
Whoa.
Just do it for 2 seconds.
Are we talking about our F prime?
And you care?
Yeah.
Or is it just me?
No, I'm doing the original. So it's 1 over.
1 plus e to the negative x.
I carried 3, but I lost all 2.
Then I
3
got
could just be yours.
Or another one.
It's like a.
You put the wrong
Because then
sign.
that just makes me lose this one.
Yay.
You sure? I want the same color.
That looks like my driveway.
How much about?
Yeah, because it has to go up.
Oh, okay, I see what you're
It looks like a speed bump.
And does it look like there's a concavity change? There's.
No.
No, not really sure on this one. Okay, now. We only did the first derivative, so now I have to do the second derivative, right?
Yes, sir.
So second derivative, hopefully, according to my graph, hopefully would give me what? Where's it going to give me concavity at?
Third derivative. I mean second derivative.
Second derivative, right?
Sure.
But what do you think that one should come out to be?
Positive.
Look at the graph and tell me what you think it's going to come out to be. Your second derivative equal to 0. Do we have a concavity change here?
No. Oh, so it's gonna be.
Does it kind of looks like it?
In the middle.
It's like-
between-
Maybe.
between-
It does, because
between
it
negative
stopped.
2 and 2.
Between -2 and 2?
Yeah.
Somewhere in there, yes.
It's not.
You gonna test it?
Today's Wednesday.
No, tomorrow.
Tomorrow's Friday.
Tomorrow, then.
I've had
What about Friday?
Is it anime?
Is it something like this? If I look like it, what it? Just looking at this. Look at the left side. Does the left side look like it's concave up?
It goes like this, like this.
It looks kind of like it's concave up. What about the right side?
Look at it like this.
Look like it could be concave down, right? But it doesn't look like it's going to be anywhere from there. But it looks like there might be a change in concavity. Where?
0.
0.
At
Under
0.
reflection.
Okay.
Point where it flips.
So, is there a way of actually doing this?
So,
Now, I'm going to show you guys a trick right now.
Joyce, have you
Okay.
only fixed your-
So watch this. So hit this menu.
Showing us a hick.
analyze.
And what do I want?
DYDX. Holy cow.
Rah, ah.
Rah rah.
No way.
With the rah rah. With the rah.
That just like.
There we go. Ah, there we go. So right here. So looks like we have right there. So this is the slope all the way here, right? So it looks like it keeps changing. It doesn't look like it's starting to go down. Okay, it doesn't look like it goes all the way to 0. Okay, let's try another one. So I'm gonna watch this. F2.
F2.
Now, what should I put in the second?
Our derivative.
Put my second derivative, right? I'm sorry, my first derivative.
And then you did DYDX on that one.
Yes.
Well, that's insane. Well, like for the calculator portion, this is a major hack.
But the non-calculator portion, this is just.
So this is was it e to the x, right?
Yeah. Over e to the.
What the heck?
I don't know.
We can do that?
Okay, so yeah, because you can inverse the function like that. So we have e to the positive x, right? All that's going to be over. This is frustrating. My computer is so laggy.
Your ping too short.
What is this?
E to the 2x.
Okay, so I have e to the 2x.
Plus
2e to the x.
Very good. Plus 2 e to the x plus 1.
Yeah.
So we have that one there, right?
Oh my.
Okay.
That's
So
that's the first derivative.
this is the first derivative. Okay, so if I take my menu,
dy dx. Holy
dy dx of my first derivative,
Excuse me. Sorry.
Spoiler alert. Spoiler alert.
Bro, your
Sorry.
grap's gonna be famous, dude.
I didn't think you would.
if I'm looking, look, you guys, can you see it right there? It's kind of gray.
So that means it's concave down.
So right here, this is negative over here, so this side is now concave
Down.
down, where this side right here is,
Concave up.
Wow, this matrix has this.
yes, concave up. So I have positive, so that means at 0 is my, oh, I was able to see it right there. Can you guys see that on the screen? So right there, I have my derivative, I have my first derivative here, right?
Yep.
So given the first derivative, I could use my calculator to take the derivative at a point. So I'm using my little trace function here, and at 0, my value is 0. So that means the derivative of the derivative, which is my second derivative, at 0 is equal to 0. So that means that right here, that is my point of inflection. I have a point of inflection at 0. So on the left side of it, because I have positive numbers, that is all concave up. On the right side of it, I have negative numbers, so that means that is all concave down. Now, you're going to see something like this on the exam, on the AP exam, okay, where you have a calculator. Your variable you have available to use the calculator. Now, doing this trick, this helps out, especially in a multiple choice type of answer. Okay, that's what we're talking about here. On the calculator portion, 30 questions, multiple choice. This is one way to actually go through and figure it out real quick. Okay, yes, the derivative was a pain, but all you have to do is set up the derivative. You don't actually have to do the algebra portion of it. So you could actually just set it up what we had at first. So I'm going to escape, because I know you're paying attention right now.
Yes.
So watch, I'm going to F3, and when I did it on the board, before I did any of the work, I could just use, let me go back a page, right up here. So I could just use this one right here.
Yeah, I was about to ask. Can you just do that?
Yes, I could do this into my graph right here. Hey, boss. Say hi to my fans. All right, so now we're entering this. So now, okay, because I know you guys have this written down, so we're going to take a look. So it's going to be a negative, right? So it's a negative, parentheses, 1 plus e to the negative x, very good. So, and then we're going to close that one, and then open it times what?
Wait, there's a
It's to the negative.
power.
Oh, it was to a negative power, I'm sorry. Negative 2?
Yes.
There we go. And then over, what was this one?
Negative e to the negative x.
So negative e to the negative x. Close that. I'm sorry.
Oh, I just did my correct.
Like, is that it right there? So what is this one supposed to match?
Second derivative.
It should match my, so it should match the red line, right?
Yeah.
So it should match the red line. So if I hit enter,
Oh my gosh.
Wow.
so all that algebra that we did, you could put in the calculator to be able to sketch your graph on that one.
Why is it asking for a slider?
Then because you messed up something.
Wait, so when we sketch
That's
the
for
graph, do we sketch the graph of the
Negative
derivative?
1 plus x.
Okay, so I did of the function in the first place, right? Blue is my function. Okay, so from this one, just looking at here, can I test for concavity? I can kind of look at it and see, oh, hey, this is concave. It looks concave up on the left, and it looks concave down on the right. but there's only one way to actually truly know. So we took the first derivative, and then I did the calculator to find the derivative at a point. So it looked like it was changing concavity at 0, so I just traced over it, and I was able to see, oh, this side is negative while this side is positive, and so I know that there is a change in concavity there. So the left side is concave up, or the right side is concave down.
So then in the paper you want us to put that's like it's changing concavity at 0? That
Yeah.
would be like
Yes, we would. Yes, we would have that. That is our point of inflection. So concave up would be from negative infinity to what?
0.
0, and concave down would be,
Parentheses 0.
yeah, so it would be parentheses 0 to positive infinity.
Close parentheses.
Yes, very good. All right, so let's take a look at the next question. Next question is not going to be the calculator one, I hope.
Bracket on infinity.
So it's
Whoa.
All right, so I have fractional exponents here.
Bless your soul.
Pick cube.
So that's like kindred spirits.
Oh my god.
Okay.
Just had to be extra, man.
Make Satan.
All right, so let's go ahead, take the derivative. Take the derivative, so I'm going to end up with what?
10 thirds x to the 2 thirds.
2/3, very good. Because I'm subtracting, right?
Yep.
I have to subtract 3 over 3 for my exponent.
Negative 20x to the 1/3.
Minus
20x 1/3.
20 over
3.
x to the,
1/3.
okay?
Oh right, I was like, where'd that third come from? But I remember now.
Okay, so think about it. Do I have any restrictions here?
No.
No.
Why?
There's no
There's
denominator.
none
if it's odd.
Wait.
It will never be used
Power
against
is
the
odd.
Okay,
There's no
that's right, that's
there's
right.
no x in the denominator.
Yeah.
Okay, nothing in the denominator, but I have fractional exponents. In a fractional exponent, the top
Oh.
number is
if
the
it's a-
power, and the
root's
bottom
the
is
root.
a
But
root.
since it's a cubed root, there's no restriction.
That's why. Okay? So, because of this, right here, I'm just going to pick on this one here. The same thing for the other one. So the top number is a power, the bottom number is a root.
Flowers.
So this is a third root. Okay, with third root, I'm allowed positive and negatives. With even powers, or I'm sorry, even roots, I'm not allowed that. Right? So that would be a restriction. So I would not be allowed to have certain type of problems because of it. Yes?
Yes.
Okay, so let's go ahead and set this equal to 0.
Big roots.
Take out
X
X.
to the 2/3 minus 23x to the 1/3. Okay, so what could I do here? Say F that. Someone say F that.
F that.
Can you factor that, please?
So I'm going to take out what?
And X.
10 thirds.
10
I'm-
thirds X.
10/3 x to the
1/3
1/3. Very good. And I'm going to be left with
X to the 1/3. Yeah.
1/3.
Plus 1.
And?
Minus
2.
Minus 10 thirds.
10 thirds.
Okay, I took out 10/3, right?
Yeah.
So I'm going to have
Oh, 2.
2
Oh, okay.
equals
That makes
0.
sense.
Okay, so now this right here is going to equal 0, right? So I have x equals 0 here. And when I move this to the other side, x is going to equal,
The cube. No.
I have to cube it to get rid of it, right?
2 cubed.
2 cube is,
8.
Ocho.
so those are my first derivative. So that's going to be the place in which that's going to be equal to 0, right? So those are my mins and maxes. Okay, so I'm going to pick this up again tomorrow, right here. Same bat time,
You gotta pick up your laptop.
same bat channel.